Hello everyone, and welcome back to the Fluctus Channel. Jet engines changed aviation by replacing the pull of propellers with the enormous thrust of fast-moving air. Early turbojets appeared during the Second World War, but modern turbofans now power airliners, bombers, fighters, and heavy cargo aircraft across the world. Their basic idea is simple: pull in air, compress it, mix it with fuel, burn it, and push the hot expanding gases rearward to drive the aircraft forward. The danger begins at the intake. A large engine does not merely breathe air, it creates a powerful, low-pressure zone in front of the fan. At takeoff power, the airflow can pull loose tools, hats, cones, luggage straps, or even a person toward the spinning blades in seconds. The bigger the engine and the higher the thrust setting, the larger the hazard area becomes. Some of the world's largest turbofan engines, such as those used on wide-body jets, move more than 1,000 kilograms of air every second. Their fan diameters can be wider than the fuselage of a small business jet, and their blades rotate with enough energy to destroy anything entering the inlet. This is why ramp markings, safety cones, hand signals, and headset communication matter around every aircraft. A frightening intake incident begins almost invisibly. The aircraft may be parked, lights flashing, engines running, and ground staff working nearby. Loose objects first slide across the pavement. A bag, cover, or piece of equipment lifts and vanishes into the inlet. If a person enters that danger zone, the airflow can overpower balance before there is time to react. Once the engine swallows debris, the fan blades can shatter, the compressor can surge, and the aircraft can suffer serious damage before takeoff. Safe baggage loading prevents this chain from starting. Ground crews first wait for clearance from the flight deck or ramp supervisor. They approach only from approved directions and stay outside painted engine hazard zones. Chalks are placed, cones mark safe working areas, and belt loaders or baggage carts are positioned carefully near the cargo door. Workers keep straps, tags, plastic wrap, and small items secured because even lightweight material can become dangerous near an intake. Bags are loaded in a planned sequence. Heavy items go first or into assigned positions to maintain aircraft balance. The belt loader is adjusted so baggage moves smoothly into the hold without falling onto the ramp. Inside the cargo compartment, handlers stack bags tightly, use nets or barriers where required, and report when the hold is complete. The loader is lowered, the cargo door is closed, and equipment is pulled away before engines spool up. Jet blast behind the aircraft creates another hazard. Exhaust can throw carts, cones, and personnel across the ramp, especially when pilots increase thrust for taxi or engine checks. Ear protection is essential because noise levels can damage hearing quickly. Eye contact, clear signals, and strict zones keep everyone separated from both suction in front and blast behind. The routine may look ordinary, but every safe departure depends on discipline. Modern engines are engineering miracles, yet on the ground they behave like invisible industrial machines. The safest worker is the one who treats running engines with distance, attention, and absolute respect. Before pushback, supervisors also complete a final sweep for forgotten tools, unsecured panels, open latches, and loose cargo equipment. Headsets connect the ramp lead with the cockpit, So engine start, brake release, and taxi clearance happen only after the ground team confirms that everyone is accounted for and all vehicles remain behind the safety line, away from engine danger zones. Another danger arrives from the sky itself. Bird strikes happen when birds or other wildlife collide with aircraft, especially during takeoff and landing when airplanes fly low, fast, and close to habitats around runways. A single small bird can dent a leading edge or crack a windshield. A larger bird entering an engine can bend fan blades, trigger vibration, reduce thrust, or force an emergency landing. Airfields attract wildlife for several reasons. Open grass offers feeding space, drainage ponds draw water birds, insects attract flocks, and nearby farms or trees provide shelter. Military bases face additional risk because fast jets, tankers, bombers, and trainers often operate at high power and tight schedules. A strike that damages an engine can ground an aircraft, threaten the crew, and interrupt the mission. The U.S. military manages this danger through bird, wildlife aircraft strike hazard programs, commonly called BASH. Wildlife specialists survey airfields, identify species, study movement patterns, and recommend ways to make the environment less attractive. Grass height may be controlled, standing water reduced, trash managed, and nesting areas removed when allowed. At Joint Base San Antonio Randolph, wildlife work around white-winged doves showed how specific species can become aviation hazards. Specialists monitor where birds feed, roost, and cross flight paths, then design control measures for that local behavior. The goal is not random noise, it is understanding why the birds are there and changing the conditions. At other bases, crews use bird cannons. These propane-powered devices fire loud blasts at timed or irregular intervals, startling birds away from runway areas. At Ellsworth Air Force Base, bird cannons became part of a wider effort to protect aircraft and personnel from strikes. The devices are moved or adjusted so birds do not become used to one pattern. Falconry provides another method. During NATO's Baltic Air Policing mission, trained birds of prey helped clear airfields by creating a natural predator presence. Handlers release or position the raptors under controlled conditions, encouraging gulls, crows, and other birds to leave the area. The technique works because many species recognize the danger instinctively. BASH is therefore a combination of biology, airfield management, sound, patrols, reporting, and pilot awareness. No system removes every bird, but layers of prevention lower the chances that a flock will meet an aircraft at the worst possible moment. The work begins before engines start and continues after the last aircraft lands safely each day. The consequences of a bird strike can appear instantly. On the 19th of September 2021, a U.S. Navy T-45C Ghost Hawk training aircraft suffered a bird strike while approaching Naval Air Station Joint Reserve Base Fort Worth in Texas. The strike affected the aircraft during a critical phase of flight, when altitude was low and time to recover was limited. The cockpit view captures how quickly a normal approach can become an emergency. The aircraft is descending toward the runway when impact occurs. Warning cues, changing engine behavior, and the loss of normal performance force the crew to make decisions in seconds. The instructor and student pilot ejected safely, while the aircraft crashed in a residential area near Lake Worth. Homes were damaged, but the aircrew survived. Incidents like this explain why aircraft components are tested against bird impacts. Engineers use special test rigs to fire bird-like projectiles or substitute materials at windshields, engine inlets, leading edges, and other vulnerable sections. The goal is not to make aircraft indestructible. It is to prove that critical structures can survive defined impact levels long enough for crews to react. Engine testing is especially demanding. A bird entering the inlet can strike fan blades traveling at tremendous speed. Designers must show that the engine can contain damage, avoid throwing fragments through the casing, and maintain enough safety margin for shutdown or controlled flight. For pilots, the procedure depends on altitude, damage, and aircraft type. They may reduce power, check instruments, declare an emergency, turn back, or eject if control is lost. For investigators, every strike produces data. Species, weight, location, altitude, weather, and aircraft damage help improve prevention. The T-45 incident turned a small natural hazard into a reminder that even routine training flights remain vulnerable when wildlife crosses the flight path without warning completely. Modern airports increasingly use technology to push birds away before an aircraft reaches them. The most basic tools are physical barriers. Spikes, wires, netting, and habitat changes make signs, ledges, buildings, and lighting structures less comfortable for birds to perch or nest. At airports such as Geneva, teams combine these measures with patrols and careful monitoring because a few birds resting near a runway can become a moving flock within minutes. Radar adds a wider view. Bird detection systems such as Robin radar scan the airfield and surrounding approach paths for flocks. Unlike a person in a vehicle, radar can watch continuously, including at night or in poor visibility. The system tracks direction, speed, altitude, and concentration, helping wildlife control teams decide where to respond. If birds are moving toward an active runway, controllers and airfield crews can receive warning sooner. Lasers offer another non-lethal method. Birds often perceive a moving laser spot as an approaching physical threat. Trained operators sweep the beam across grass, water edges, rooftops, or other gathering areas, causing birds to move away without the constant noise of pyrotechnics. The method is especially useful where repeated explosions would disturb nearby communities or where birds have learned to ignore standard scare devices. These systems still require human judgment. A radar return must be interpreted. A laser must be aimed safely. Spikes must be inspected. Habitat changes must follow environmental rules. Wildlife officers decide which tool fits the species, time of day, weather, and airport layout. The future of bird strike prevention combines data with rapid response. The objective is simple: keep wildlife away from engines, wings, and windshields during the few minutes when aircraft are most exposed. From the first jet engines to modern high-bypass turbofans, aviation has gained speed and power. But ground and wildlife hazards remain unforgiving. A running engine can pull objects in before anyone reacts. A bird can damage an aircraft in a single impact. Safe operations depend on trained crews, protected ramp zones, disciplined loading, smart airfield management, and technology that spots dangers early before a routine movement becomes a disaster in a matter of seconds. That is the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.